Hi, and welcome to General Physics 2 at the University of Northern Iowa for the summer 2024 term. This is a brief introduction to the structure of the course and the course policies, primarily intended for those that are participating in the course asynchronously on your own schedule. If you are coming to class on Monday, May 13 at 9 o'clock, or you already came to class, the content of this is going to be very redundant of what was said there. So, what do I assume about learning physics? Well, the very first time that I taught physics, after that year, some of my students told me that I used two words over and over again during the course of that class, and the words were intuitive and trivial, which are two words that I've tried to scrub from my vocabulary in teaching introductory physics since then, because for most of us, physics is not intuitive. There are some strange ideas that physicists have uncovered about how the universe works, and for a lot of us, it's quite a bit of work to make ourselves make sense of those ideas. And there are not really any trivial ideas in here either. They are, I don't know, at least from my perspective, big ideas and important ideas about how nature behaves. So I've actually come around to thinking that learning physics is actually a fairly difficult undertaking for most people, myself included. I've been doing this introductory physics for long enough that it doesn't feel difficult to me any longer, but there are some ideas in physics where I read a paper and it's still, a mind-boggling experience. So I think for most people, learning physics by just doing what you're doing now, listening to somebody talk about physics, is a mostly ineffective way to learn physics, or at least if it's used only that way, is an ineffective way to learn physics. I think it's best to learn physics by actually doing physics, and I think myself and other physics professors keep assigning homework in physics because we realize that we learned the majority of our physics when we were sitting down there trying to crank through a problem, or we were in the lab trying to make sense of some of the data that we were recording. And so we continue to ask students in physics courses to do those same things in the hopes that those activities will help them to learn the concepts of physics. So this course, even if you are choosing to participate in this online, will involve conducting experiments. It will involve performing calculations. It will involve thinking about the concepts of physics, hopefully in a way that stretches your brain a little bit and gets you to appreciate this way that nature behaves. I also, ascribe to social learning theories that say learning can be done effectively in a group. And so if you choose to participate synchronously in the course, anybody that's doing that will be forming a small group where we're working through the tasks of the day. But if you are participating asynchronously, I would encourage you to consider reaching out to one or more people in the class and setting up a small group that works for your schedules where you can work on some of the class activities together. It can be very helpful to have somebody else in the struggle there giving ideas and reacting to your ideas. So this course is delivered, or at least the content of this course is delivered through the Blackboard portal. It's e-learning at UNI. And this is what the class page looks like when you get there. There was a separate video that sort of walked you through where things are on the Blackboard page, so I'm not going to do that other than to re-comment that this is my first time using the Blackboard Ultra system, and there are still things about the way that that is structured that I'm getting used to, so I ask you to bear with me as I figure out some of the bells and whistles of Blackboard Ultra. What do you need for this course? Well, primarily you need to have access to the textbook and assignments for this class. And the way that we do that is through access to a digital text and a digital online homework platform called Mastering Physics. These are offered in what the bookstore calls an inclusive access package. And so the first time you click on one of the links from the course to take you over to this Mastering Physics platform, you will be asked whether you want to opt in or out of that. Again, I think this is the by far cheapest way to access these class materials, but if you have another route, you can opt out of that. You just need to make sure that you have a way to complete the assignments on Mastering Physics. A second thing that is not digital is the student workbook that goes with the textbook. I find this an incredibly valuable resource for actually learning and practicing the things that are in the chapters that we're reading. And so during scheduled class time on certain days, we're actually working through workbook sessions together, answering those questions. If you are doing this asynchronously, you should still be doing those workbook exercises on your own. So you'll need to purchase a workbook. They should be available at the UNI bookstore, but the UNI bookstore is not always the cheapest way to get things, and you certainly can order these online as well. Just one note, when we get to the final unit of this course, there are a couple of chapters that actually are in the Volume 1 workbook, because I go back and revisit the topic of waves there. So when we get there, I will give you some access to some digital copies of those particular chapters. So you do not need to buy a Volume 1 workbook, but if your instructor for General Physics 1 used the workbook and you still have it, we will look at a couple of those chapters at the end. A calculator is a very useful thing, especially when you get to doing problem sets or exams. So I would encourage you to have a calculator that has some trigonometric functions on it. If your phone is your calculator, that's perfectly fine with me. You don't need to go buy a new calculator to do this class. So how is the course structured? Well, I structure this within every unit, 2 to 4 of these learning cycles, where we actually start by doing a laboratory experiment. And that could be one of 2 ways. It could be just an exploration that is asking you to observe phenomena and look at the patterns there, but not necessarily record numerical data. Or there could be a lab where we have a question that we can actually measure things and we can record quantitative data and look for the mathematical relationships between those variables. So those are either exploration or modeling labs. Then, following work in the lab, we ask you to do one of 2 things outside of class. Either read particular sections of the chapters in the textbook, or watch the online lectures that are over that same material, or you can do both. And in fact, early on, I would encourage you to do both to see which one seems to be more helpful for you learning that content. When you've completed either or both of those, we move on to the workbook exercises, which allows us to practice the things that we covered in the chapter there. Following the workbook exercises, we work on some problem solving. If you are participating in class, that will be in the form of group problem solving, where I walk you through how to set up and solve a problem, then I ask you to set up and solve a similar problem to get you the practice that you need before you move into doing the problem sets, which again are delivered over the Mastering Physics platform. And the problem sets that you're assigned are actually set up so that there are some required problems in each problem set, and then there are additional optional problems that you can use for further practice should you choose to do so. The course is scheduled and delivered. The schedule is actually delivered 2 different ways. So there's a link on Blackboard that takes you over to a Google Doc that has this schedule, but that doc has 2 tabs in it, and I would encourage you to look at both of those. Number 1 is a calendar view, and so in this calendar view, it tells you during scheduled class time, here are the activity or activities that we're going to be working on again in that 9 a.m. to noon window. And then there's a series of things that you are asked to do outside of class time, because we can't get everything into the 3-hour window in the mornings there. So that's the structure on the calendar, and if you are planning to participate with us synchronously, that's what's on deck every day. If you are doing this asynchronously, the more useful approach is the tab that has everything in checklist view, which tells you what activities you need to do in order to complete each of the units within this course. I will point out that exams are already scheduled, and so you can see the exam dates on the schedule here. If you are doing this asynchronously and you are choosing to take exams at a different time than scheduled, you will need to do so with a proctor. So please read in the syllabus for the policies that cover that particular option. The unit exams, when we have them, consist of some numerical problems, which are similar to the kinds of problems that you do on the problem sets and in the class problem solving sessions. They will also have a couple of questions that are more conceptual in nature, so they don't have a lot of numbers to them. They may not have things to calculate, but rather for you to explain or diagram or some combination of the two. So they are similar to both conceptual questions that we have from the text and really very similar to the workbook exercises that we work through out of that. I always put a handful of multiple choice questions on my tests because many people that are taking this class are taking it because sometime in their future they have to take a physics test, an MCAT or a GRE or something that has physics on it with multiple choice questions. So those multiple choice are designed to give you some practice in answering those types of questions. Anytime we get to a unit exam, you can use a one-page sheet that has whatever you want to put on it, as long as you made that sheet yourself. And prior to the exam, there are practice exams available. So if you want to, you can see what the format of the tests look like, and you can, in fact, practice answering the questions on those practice exams, though those questions are not the same questions that you'll see on the actual unit exam. Several years ago, I actually instituted this policy after hearing about a colleague who did this, but on any unit exam, there are also makeup exams available. And so if you are not happy with the way your score turned out on your first crack at the unit exam, you can take the makeup exam. And what happens is your unit exam average becomes the average of those two scores. So you do have to study and make sure that you improve your performance on that makeup exam. But if you do so, your grade does go up, and you can see more details about that policy in the syllabus. Pragmatically, this is what most people care about. How's my grade calculated in here? And so you can see that 5% is pre-tests and post-tests, 15% is for the problem sets. Get a little bit of credit for completing the workbook exercises. There are lab reports. You don't have to write a lab report for every lab in the course of this course, but you do need to write a lab report for one laboratory experiment per unit. Those are 10% of your grade. Each of the unit exams is 15% of your grade, and then the comprehensive final exam is 20%. There are also some conceptual tests that I administer both as pre-test and post-test in this class. They're based on research people have done into student learning and what topics are often difficult for students to learn. They help me gauge what materials are and aren't effective in this class. And especially when we take them as pre-tests, you're not expected to know the answers to any of these, but I am curious to know what you know before we start the course and what you know at the end of the course. So I do ask that you give them your best effort, however you get full credit toward your course grade just for completing them. So what do you need to do to start out in this course? Well, you need to post an introduction to yourself in the discussion board that's up there on the Blackboard e-learning page. You should read through the syllabus and take the syllabus quiz. You can take the syllabus quiz twice if you don't get the maximum score on the first time. You take those two pre-tests. One's on scientific reasoning and one is on electricity and magnetism. You should make sure that you can access the Mastering Physics page for this course. If you wish to do so, you can complete those optional Mastering Physics assignments that introduce you to the platform and review some important mathematical concepts.